Hi guys, welcome back to another tip from my GSD lab. This is tip number 3. We called tip number 3 configure your server storage. And we gave it a bit of a generic name because we tried to put together on this tip a lot of stuff, right? So we can go through a lot of scenarios, of the stuff that we need to do with storage. So let's just get into it. First thing, if you have a gold membership, you can actually online server. I have it open here, right here. So let me just read my first exercise. So the first exercise is to create a logical volume named data with 128 megs in a storage group named Datastore, and then to ensure that the file system is XFS and automatically mounted in directical data. All right, so let me just zoom in a little bit so we can see better here. So let me just log into my server, and the first thing we need to do is just to check to see what sort of what do we have available as far as this. So to do that, we do a cat on proc and then partitions, and that's where we have some information about whatever partition we have created and the disk that we have created. If you look closely, we have VDB. That disk doesn't have any partitions created, so let me just use that one. To do that, we use fdisk and then dev VDB, right? So what we're going to do is to create a partition that we can then use to create a physical volume on that partition, and then with that physical volume we can create a volume group, and then using that volume group then we create a logical volume. So it's a little bit of a long process, so let's just go through it step by step. So the fdisk utility, the minute you enter, it gives you press N for help, which is actually what it really gives you is a menu. It tells you what you can do. So what we're going to do is just add some new partitions. For that, we press N. So obviously this is going to be our first partition. So we create a primary partition. That should be sufficient. The partition number is number 1, no problem. The first sector is whatever first sector is in there, and if you remember, it's asking us to do a 128 megs volume group, logical volume. So we're going to, as the last sector, we're going to do plus, and let's do 140, right? 40 megs, because we need just to be around 128 by the time we get to the file system. So 140 megs, and it says that partition 1 of type Linux and of size 140 megs is set. So that's actually important to understand. We cannot have a partition type Linux. We need to have a partition type Linux LVM, right? And to change the partition type, we can press menus to see how to do it, but we press T, which is the change the partition. It says change the partition system ID, but it stands for type, and then we need to enter the hexamal, the hex code for the partition type that you want to change this partition to. But we can, obviously it's very hard to remember all those codes. For Linux LVM we need 8E, but if you don't remember, you press capital L and it will give you all the partition types right there, right? So 8E is the Linux LVM, which is the one that we need right now. So we enter the hex code HE 8E, and we're good to go. Press P to verify that we have done everything we need to do. So we have a Linux LVM system, and to exit we press W, which stands to write, right? Next thing, the minute we do a change on a hard drive, we need to use the utility part probe, just to make sure that we sync. We can just use it like that, or use it directly on the hard drive, but just to make sure that we sync the partition table, right? So that's it. We go through it. Perfect. So proc partitions. Then we see VDB1 right there. So we have already a partition created on a hard drive. So the next step will be to create a volume group. So to create a volume group, we do VG create. I always like to use minus minus help to make sure I don't miss anything. So if you remember, the volume group name is Datastore, and then what's important here, they're not asking us for anything anything different, like changing the physical extent size or anything like that. So we can just all the options, right? And then we can enter just the volume group name, which is Datastore. Sorry, the store, and then the physical device path. Now, usually we should create a physical volume first, and then create a volume group. But by creating the volume group and assigning a physical device path, it's just going to create a physical volume on that device. So dev vdb1, enter, and that's it. So if you see, it says physical volume vdb1 successfully created, and then volume group data store successfully created. So it does both things, right? You don't have to do physical volume pv create first and then vg create, so you can just put both of them in the same comment, right? I hope that's clear. So the next step is to create the logical volume group. So lv create minus minus help, just to right. So lv create, and what we need here is to tell, we need a name, because it's asking us to create a logical volume named data, right? So we need minus n, and then we see data, right? And then we also it is for this comment, the size of the logical volume is mandatory, so it's not an optional. So let's do minus L, and since we created the partition to be as close to 128 megs, which is the requirement, as possible, we can we can use lowercase l and do plus 100% free, right? We can always do a capital L and enter 128 megs, but I like to do it like this, just to to use all the storage that I have available on the volume group. The next thing is the physical volume path, right? So we need to say, right, sorry, the next step is the volume group. So data store. It's telling me that it has an XFS signature, obviously, because I used this this device earlier. Perfect, so it's created. All right, so we have a volume group. To verify that we have a volume group, we use VGS, which stands for volume group summary, and we see it there. It's data store, and then we have a logical volume, and we use LVS, which is logical volume summary as well, and we see that we have a data that belongs to the volume group data store. Perfect. So what we need to do is to create a file system on this volume, logical volume. To do that, we do mkfs, and it's asking us to do an XFS file system. Let me type minus minus help just to show you something. After we create the file system, we have to mount it. And to mount it, then we need to create an entry for this file, for this logical volume into the FS tab. So I don't like to remember those long long things of dev or whatever. So I always like to add a label. So let's just add a label, so we can use a label to mount this logical volume on boot. So minus L, we call it data, and then that's it. We need to use dev, and then the volume group name, which is data store, and then inside the logical volume name, which is data. So that's going to format that logical volume into and give it an XFS file system. If we do block ID, let me just grab that data. We have a label called data, and that's what we're going to use on the FS tab file. So let's do vim etc FS tab, and let me just go up there, and here we're going to enter all the parameters that we need to mount this logical volume. So label, as we said, we're gonna use the label equals data. It's easier, right? The next thing is to tell the system where to mount it, which is / data. Then the file system, which is xfs, and then the options. I'm gonna use defaults, and then 0 and 0. This is for to tell the system is if you're allowed to back up this partition, and if you need to do a file check on boot. So I add both of them 0 because this is we're just testing. So let's just save that, and now we need to create the directory where we're going to mount it. So mkdir data, that's done, and we need to make sure that what we did works. So to mount everything that's on the FS tab, we do mount -a, and that way we already test that the configuration we entered on the FS tab actually works. So mount -a, it didn't complain. So in Linux, no news is good news. So df-h to verify that we have it mounted. So Datastore on the last line is 133 megs, a little bit more than what we said, right? You have 126 available. It is mounted successfully on the directory data. Very good. So that's the first exercise. So let's do the second one. The second one says increase the logical volume data to 256 megs. Right. So what we need to do, just the newly created logical volume, we need to increase it to 256. So for the logical volume for us to extend the logical volume, we need to have sufficient space on the volume group, and we also for us to have sufficient space on the volume group, we need to have sufficient space on the physical groups. So the first thing we need to do is just create another repartition the disk and create another partition just to add it to the volume group. So fdisk, if you remember, the disk that we were using before was dev vdb, and let's just print to remember what we had over there. So yes, we have only one partition, so let's create a new one. We created a primary partition. We still, it's just a second partition we're creating. Call it number 2. We start right there, and the first is gonna be 140 megs. The last sector we do plus 140 megs, and that's going to create a partition 2 of type Linux, size 140. If you remember, we need to change the type, pressing T, to Linux LVM, right? So default, we're going to change the type of number 2, and then the X code is 8E. But remember, if you don't remember the hexadecimal code, capital L, we show you, all of the hexadecimal code for the partition types. So Linux LVM is 8E, so it's right there, and that's it. We just write and save it. Done. So part probe, and I'm gonna do part probe only on the VDB, just so I don't have to do it everywhere else. It's actually a little faster as well. Perfect. So I should have now a second partition. So let me check. Proc partition, and I have VDB2, right? So what I need to do is to extend my volume group, right? VG extend, right? As I said, again, by extending the volume group, you can add a device to your volume group, and it will create already a physical group. So the help for VG extend, which stands for volume group extend, is the volume group name and the physical path, right? So we basically extending data store, right? And we just adding one device, which is VDB2. And physical volume, dev VDB2 successfully created, so we didn't have to create another physical volume. And then the data store was successfully extended. So let's look at the summary for VGS. What does it say? It says data store has 2 physical volumes, and it has a size of 272. So we need 256 in our logical volume. So we have sufficient space to extend our logical form. So let's go there and do it. LV extend minus minus help. One thing important here, if we extend the volume group, then we need to extend the file system. But you know, LV extend has an option which is minus R that will allow you to resize the file system once and for all. And you know, I just use that option, you know, and get it over with. So then minus L, capital L. I'm gonna add the. Actually, I'm gonna do plus 100 free. Sorry, 100% free off, and then we need to enter the logical volume path, right? So def Datastore, sorry, data. Okay. There we go. So we have already extended the logical volume, and we have also extended the file system. So let me check on something. If I did we still mounted. So new mount data, and then let's mount minus A. And do a df minus h to verify what we've done. Sorry about that. And perfect. We have you know, data was mounted is 269, and you have 255 megs available. So we're very close to the 256. When working with logical volumes, you know, it's very hard to be you know, very precise on the size. Okay, the next assignment is to create an encrypted partition and format the file system and ext4 and mount it automatically on the /secure. Creating an encrypted partition is a little bit more complicated, so let's go ahead and do it. Let me clean this up a little bit and zoom in again. Alright, so let's create. We need to understand the distinction between the partition and the file system on the encryption layer, right? So we basically have to create a partition and format it, you know, with an encryption layer, and enter a passphrase for that encryption layer, and then open it. And then after we open it, then we create a file system, and then we mount it. It's a little bit confusing, but you know, let's go and do it. Maybe that sheds some light on it. So let's use the same device that we were using before. I think we still have some storage there, so we do fdisk on def vdb, and again we do n for new partition, and let's create we have two primaries, right? So we still have two additional partitions that we can create primary. If not, we have to create an extended partition. So let's create another primary partition, partition number 3, the first sector, and then it's telling me to create an encrypted partition with 128 megs. So we do plus 128 megs, and that's it. So we already have partition created. It's a Linux partition, and now we do W to write it. Obviously we have that interesting warning that is basically telling us to run part probe on the device. That should be it. Now the next step will be to format that device and adding that encryption layer, and the tool to do that is called crypt setup, and we need to do format, sorry, we need to do looks format and enter the device name, which is VDB3, I believe, right? And then it gives a warning there, and you need to read, right? It says type uppercase yes. If you type yes lowercase, it doesn't do anything. So we type uppercase yes, and it's gonna ask you for a paraphrase. The paraphrase needs to be complex, so enter something that you will remember later. Otherwise, you won't be able to, you know, enter your system. And see, that passphrase is gonna be used every time you start, you mount this encrypted partition. So the next step would be to open that partition, and to open it, we need to give it, and we're gonna open it as secure, right? No, secret. So we need to call it secret. Perfect. Create a tab, it's open, and we're gonna call it secret. It's gonna ask you for a passphrase that we just entered. So we just enter your passphrase. We're done. That's it. Now we have already the device encrypted, and we have as well we have the device open. So the next step will be to create a file system. It's asking us to create an ext4 file system. So mkfs .ext4. So a lot of people think that, make the mistake of trying to create the file system on dev and VDB3, which is a physical device, and that is a big mistake. What you basically do is you just erase everything you're doing right now. So the fact that you just open that device encrypted, it means that it's now open on the mapper, right? And so we do dev, and we do mapper, and then secret, and that's the actual device that you need to add a file system to, right? Again, we're going to add a label, because we're going to use labels on the FS tab by the time we mount it. So secret, right? And then we give it a file system. So perfect, right? In super blocks, everything done. Perfect. So we have a file system already. The next step will be, to make sure that by the time we boot, we have to first open the encrypted device, right? So and then after we open it, then we need to mount it. So these are two steps that we need to create. The first step is done, modifying the file etc crypto tab, right? And on crypto tab, we just enter the information for that we just created. So we call it secret. Secret, and then the device name, which is dev vdb3, right? Secret. Let me see if I spelled it correctly. Secret vdb3. Perfect, no problem. So we save that. That's it. So let me just clear the screen a little bit. The next step will be to add that device. If you remember, let me just do a block ID. I created a label called secret. So let's make sure that we can mount this encrypted device on boot. So etc fs tab, and then same thing. We're going to use a label to mount it. We're going to give it pretty much the same. Secret, right? We're going to mount it in a directory called secret. File system is ext4, then defaults, then 0, and then 0. All right, let me see if I misspelled something here. No, everything seems to be in order, so perfect. When you're creating an encrypted file system, I strongly recommend you to reboot. But let me create the directory secret so we can actually mount it somewhere. So mkdir secret, and then mount -a. That's gonna mount that map to the secret directory. But I always recommend you to reboot. We're gonna reboot in a minute, because the problem is that we have another exercise that we need to finish, and I want to do it first. But I always recommend to reboot just to verify that the encrypted directory, the encrypted device is actually open. So let's go back to the last exercise. So we're almost there. The last one is to create a new 128 megs swap partition. Perfect. So 128 meg swap partition. Let me just zoom in again. Let's go for it. Again, let's create the partition. So fs disk. Sorry, fdisk. Def vdb. New partition. And for new. Next is partition type. So this is interesting, right? we can create an additional partition. We create an additional primary partition, but the problem is that I'm not using the entire hard drive. I still have some space left on the hard drive, so I might not want to do that. I might want to create an extended partition, then create logical logical partitions in it. So let me just create an extended partition. I'm going to partition number 4 on, and then I'm going to use the entire, the rest of the disk, right? That's it. So I have, let me just print here just to show you something, right? So we have an extended partition, and then I can partition that extended partition in additional logical partition. So let me create a new partition, a new one, and I'm going to use my first sector as 83, whatever is telling me that's the first one, and the last one is going to be plus 128 megs. Perfect. So partition 5 is type Linux and is size 128. But we are going to create a swap partition. So we really need to change the partition type to swap as well. So to do that, if you remember, press T, and then the code is 82, but let's just verify. We press 5 capital L, and then Linux swap is hex code 82. So let's just do that. Perfect. So we have, let me just print this to take a look at it. So Linux swap, and we have VDB5, right? Let's write this, and then part probe, def VDB. Wow. That's done. Now the next step is we need to use the tool make swap, and then we're gonna make a swap on def VDB 5. All right, that's going to create the swap. Now look at this, right? When I did it, I didn't create a label, so now I have to take this info. I have to take all this to the FS tab, right? So I really don't like to put the device, because if something changes next time I boot, then this partition that I used to create a swap partition it comes back and it's not VDB5 and it's something else. Then my system is not going to mount. But I know that at least the UUID it's never going to change. So let me just do a block ID, and then I'm going to grep VDB5, and that's going to show me only that line. But then I'm going to use the awk utility to print out only the second dollar. Let me see if I remember well. Only the second column, right? And let me just verify it, and it's only the UUID. So I'm going to change. I'm going to send that. I'm going to put 2. I'm going to send that to the etc fs tab, right? So I'm not going to override it with that information. I'm just going to append, right? If you notice the 2 signs at the end, right, instead of the 1. So I'm just going to open it at the end of the line. So send it there. Now let me just edit the etc fs tab, and we should have at the end of the line the UUID. So that should be it, right? So now we need to tell it what to do with it. So it's a swap, so we don't need to swap mount swap on the directory, and it's a type swap as well. Right, so defaults as my options, and then 0 and then 0. All right, so let me zoom back in, and perfect. Let me just clean this up a little bit. All right, so we already added that information to the FS tab. So the next thing we need to do is just to swap, turn it on. So let me just do a swap on -s to show the summary, and I have only one partition, right, on my swap file. So if I do swap on -a, it's gonna take all of the swap files on the FS tab, and then mount them. So that's a way for me to verify that that I have a mistake. So if it doesn't complain, again, Linux no news is always good news. Then we have to swap partitions. So let me reboot just to verify that I can actually mount. Remember that we haven't verified that we can mount the encrypted directory. So let's just do that. Let's see if he asks me for the passphrase. Yes, he's asking me for the the passphrase that we entered for that encrypted directory. So let me just enter it and verify that everything is working fine. Log in. Just go back in and do df-h and verify that everything is there. So we have secret, we have data, and then we have the let me do swap on -s, and I have the two swap partitions. So that should do it. Thanks a lot for watching.